How are you? Today we are going to look at a topic, pressure. It is one of the topic in studying in applied science, and we start by defining what is pressure. When we talk about pressure, we talk about force, which is compressive in nature, that acts perpendicularly or normally per unit area. So the force that acts or compresses in a unit area, that's what we call pressure. So when we talk about pressure exerted on object, it will refer to the force exerted in a given area. And from the definition, you can just say that pressure is equal to force over area. Remember, force is measured in newtons and area is measured in square meters. Therefore, the SI unit for pressure, it is newtons per square meters. Or in other words, you can say it is pascals. 1 Newton square meter is equal to 1 Pascal. And therefore, in some text, in some books, in some areas, you'll find that pressure is measured or is labeled with the SI units of Pascals or Newton's square meters. Don't be confused by either of the two. So if you find 1 Newton's square meter, it simply means it is 1 Pascal. And sometimes the atmospheric pressure is sometimes expressed in millimeters of mercury or centimeters of mercury or atmospheres. And when you talk about millimeters of mercury, one millimeters of mercury is equivalent to approximately 133.32 newtons per square meters. So you can be able to even convert if you are given that. Also, let us look at pressure in solids. And when you talk about the pressure in solids, a solid resting on a horizontal surface exerts a normal contact force equals to its weight. The pressure of the solid on the surface depends on the area of the contact. Remember, it is the area of the contact at which the body is resting on a horizontal place. That part which is touching the surface, that is what we are calling the area of contact, not the surface area, not any other area, but the area of contact. So, and the weight, which is force, well, of course, the force exerted on that object, if it is resting on a table and there is no other external force, then that weight is the force which we are referring to. So, force exerted by a solid resting on surface is equal to the weight of the object, as I have said. Therefore, pressure is the same as force, which is the weight of the solid over area of contact. And remember, we said that force is measured, it should be newtons, and area of contact should be measured in the SI units, which is square meters. That is the standard one. Therefore, from this equation, you can see that area is inversely proportional, meaning that if you reduce the area of contact, the pressure increases. Therefore, if you want to determine the maximum pressure and the force is constant, then you have to minimize the area of contact. So the lesser the area of contact, the more the pressure exerted, provided the force is uniform or it is constant. So vice versa applies when you want to get the minimum pressure. You just maximize on the area of the contact. So if the area of contact increases, the minimum pressure decreases, provided the force remain constant. Therefore, you can be able to determine the maximum pressure by minimizing the area of contact. Also, you can be able to get the minimum pressure by maximizing the area of contact. What are those factors affecting pressure in solid? From the definition, you have said that pressure is equal to force over area. So those are the two factors that are affecting the pressure in solid. The first one is force, or the weight of the solid. So, and you can see from the formula that weight is directly proportional to the pressure exerted. Therefore, if the force exerted increases, the pressure also increases. Therefore, if the area of contact between solids of surface is constant and pressure increases, the weight also, pressure increases with weight, meaning that the more the weight, the more the pressure. The factor number 2 is the area of the contact of the solid with surface. So we have said it is inversely proportional. Inversely proportional simply means that when one increases, the other decreases. Therefore, when the smaller the area, the higher the pressure. If the same force is applied, therefore, pressure can be reduced by increasing the area of contact. So you can be able to determine the maximum pressure, minimum pressure. Just know that where for maximum pressure, use the minimum area. For minimum pressure, use the maximum area. And for the force, if the area is kept constant, when the force increases, the pressure increases. So if you want to get maximum pressure, you use maximum force. If you want to get minimum pressure, you use the minimum force. So let's have an example so that you can be able to understand. If the area of a contact between there is a man who is studying and his mass is 90 kilograms studied on a floor. This man is studying on a floor. If the area of contact between his feet and the floor is 0.0368 meters squared, determine how much pressure he is able to exert on the floor. So we are determining how much pressure. So we have said that pressure is equal to force over area. Remember here you have been given mass, but we want to use force or weight. And remember that weight is equal to mass times gravitational field strength, which is 10. Therefore, you have to convert those mass to weight, that mass to weight. Therefore, we say that pressure is equal to force over area. So to change mass to weight, you multiply by 10, you get 90 times 10, which is 900 newtons, divided by the area, it's already in SI units, divided by 0.0368 square meters, and therefore the pressure he is able to exert on the floor, it is 24.456.5217 newtons per square meters. So you simply remember that it is force over area. If there is a question, if what is the pressure will be exerted on the floor if now he's studying on 1 feet, assuming that his feet are uniform, meaning that they are equal in size, you just divide the area by 2. Therefore, for this case, we expect the pressure to be more because the mass will remain as constant, but now the area decreases. Therefore, and the area of contact is inversely proportional to the pressure, meaning that if you reduce the area, we have reduced by half, then the pressure will increase, and therefore, what will be the pressure? Remember, pressure is equal to force over area, then force is 900 newtons divided by the half of his area, which is 0.0368 divided by 2. Then you get 48.913 newton square meters. You can see it is doubling up because I have divided the area by 2. Also, the pressure increases by 2 because it is inversely proportional. Also, we can have another example here. We have a block of soapstone of dimension 4 meters by 2 meters by 3 meters and has a mass of 48 kilograms and is made to rest on a smooth surface, horizontal surface. Calculate the minimum pressure it exerts on the surface. Calculate the maximum pressure it exerts on the surface. For the question number 1, we are being asked about the minimum pressure it exerts on the surface. Minimum pressure, we use the maximum area. Therefore, from the dimension that we are given there, we have 4 by 2, we have 2 by 3, we have those are the two possible, and we have 4 by 3. So the possible there, for calculating the minimum pressure, we use the maximum. The minimum pressure is the maximum area of contact. Therefore, we say that minimum pressure is equal to weight over maximum area. In this case, our maximum area is 4 times 3 because that is we have possible areas is 4 by 2 or 2 by 3 or 4 by 3. And 4 by 3 happens to the maximum area of contact. Therefore, we say it's 4 by 3. Remember to convert the weight, the mass that you're given there to weight multiplied by gravitational field strength, which is approximately 10. Therefore, we have 48 times 10 to make it to 8 in newtons divided by 4 over 3, which 4 multiplied by 3 to the maximum area. And therefore, we get the minimum pressure to be 40 newtons per square meters. In question B is the vice versa. Now we want maximum pressure, we use minimum area. And from this you can see which is the minimum area. it is 2 by 3, because 4 by 2 is equal to 8, 2 by 3 is equal to 6, and 4 by 3 is equal to 12. So for the minimum area, it is 6, which is 2 by 3. And therefore, you see that maximum pressure is equal to weight over minimum area, which is equal to 480 divided by 2 times 3, then you get 18 newtons per square meter. I hope you understand how we go about the maximum pressure and the minimum pressure. So if you asked about the factors affecting pressure in solid, remember it is force and weight, and force or weight and area of contact. Area is inversely proportional, force is directly proportional. If you know how to interpret that, then you are good to go. Also, let us look at pressure in fluids. When you talk about fluids, talk about liquids and gases. So the term fluids refers to the either liquid and gases. The setup below can be used to illustrate pressure in fluids. We have a container containing a liquid, and it has a hole A, B, and C. And you can see if it is filled with a liquid, and those holes are opened simultaneously, and you can see that the hole A draws water the farthest, followed by the hole B and C, the closest. This indicates that the pressure at A is greater than that at B, and the pressure at B is greater than that at C. What does this deduce? Conclusion made from this is that pressure in fluid increases with the depth. The greater the depth, the higher the pressure it exerts. So that is one of the factors that affects pressure in fluids, that is the depth or the height of the container of the liquid. So this explains why the walls of the dam are made wider downwards. You can see the dam here. I have the dam here. You can see at the top the wall are not wide as at the surface, because there at the surface they should be wide to resist the pressure, or to be able to overcome the pressure, because at the bottom there is more pressure, so it needs wider walls to be able to overcome the pressure, to avoid the breakage or collapse of the dams. So a diver underwater experiences pressure due to the weight of water above him plus the atmospheric pressure above the water surface. So the deeper the diver goes, the greater the pressure. When a liquid is poured into a set of connected tubes of different shapes, it rises up until the levels are the same in the tubes. If you put let me have that demonstration. If you put a liquid, you can see the liquid is put in a tube, but there is a level at which they are of the same level. This shows that the liquid rises up until the levels of the same. What does this now mean? The fluid pressure formula, from the fluid pressure formula, you can be able to see that from this diagram, you can be able to see that pressure in liquid is exerted uniformly, or is exerted uniformly, and you can see from that diagram. Now, how do we get the fluid pressure formula? Consider the liquid of density, that is the symbol of density, in a liquid, in a container of uniform cross-section area A, such that the depth of the liquid in the container is h. Now, we have the liquid there, the container with the cross-sectional area A. Now, how do you come up with the formula? Remember that from the original formula, we see that pressure is equal to force over area. But this pressure, this force is the weight. And we know that weight is equal to mass times gravitational strength. So we can replace here. We can replace, and hence we get pressure is equal to mass times gravitation, which is weight over area. But we know that mass is equal to density times volume. So we can say that pressure is equal to volume times density times gravitational force over area. But for volume of all objects or all shapes is equal to cross-sectional area times height. That is definite shapes. So you can see that the pressure is equal to area times height times gravitational force times density divided by area. and area cancels, and repeat the pressure as H rho G. We can call it H times density times gravitational force. That is the pressure formula for the fluids. So the factors affecting pressure in fluids is the depth, which we are calling H, the density of the liquid, and the gravitational force, field strength, the gravitational field strength. And all of them are directly proportional. If you increase one, it increases pressure. If you increase depth, it increases pressure. Density increases pressure. Gravity increases, pressure increases, and vice versa. Therefore, that is the pressure formula for the fluids. It is thus clear that pressure in fluids is directly proportional to the H of the column H, the density of the fluid, and the gravitational field strength. We have seen that. And it's good to remember that pressure of fluid does not depend on the cross-sectional area of the container which it holds. And that's why we have tried to eliminate that cross-sectional area. We have gotten the depth and density and gravitational force. Okay, let's have an example. A diver working underwater is 15 meters below the surface of the sea. Calculate the pressure due to water experienced by the diver. Take gravitational field strength to be 10 newtons per kilogram and density of water to be equal to 1.03 grams per cubic centimeters. Here we have been given three items, that is the depth, which is 15 meters, it is in SI units. We have been given the gravitational force, which is 10 newtons per kilogram, and we have been given the density of water as 1.03 grams per cubic centimeters. We have to convert this one to SI units, so multiply by 1000 to get 1030 kilogram per cubic meters. Now pressure in liquid, you have said that it is depth multiplied by density multiplied by gravitational field strength. Therefore, it will be equal to 15 meter multiplied by 1030 kilograms per cubic meters multiplied by 10 newtons per kilogram, and therefore you get 154,500 newtons per square meters. So if you have the factors or the units that you're using, you have to use the SI units. Let's have another example. Calculate the pressure exerted by 76 millimeters column of mercury, given that its density is 13.6 grams per cubic centimeters. Here you'll be given the H in millimeters, so you have to divide that one with 1000 to get them in meters. You get 0.06 meters. Therefore, pressure is equal to H multiplied by density multiplied by gravitational field strength, or H rho G, and therefore you see it is 0.076 meters multiplied by, you convert 13.6 grams per cubic centimeters to kilograms per cubic meters multiplied by 1000. Therefore you get 13600 kilograms per cubic meters multiplied by 10 newtons per kilograms, and when you multiply that you get approximately 10,336 newtons per square meters, or pascals. So pressure in that part is 10,336 pascals. Okay, that is all about the first lesson, introduction part. We have learned about the definition of pressure in solid and factors affecting pressure in solids, how to determine maximum and minimum pressure, and pressure in liquids, how to get the formula of pressure in fluids, and we have done some of the examples. I hope you have understood. So next lesson we shall go through the how pressure is transmitted in fluids, that is the transmission of pressure in fluids. Also we shall go to the atmospheric pressure. We shall look at the measurement of pressure and the equipment that are used to measure pressure, and lastly we shall look at application of pressure. Hope you have understood, and I hope we'll be together in the next lesson. I wish you the best. I'm Mr. IKUA. I wish you have a delightful learning.